Good afternoon, everyone. Welcome to our session here on AI data challenges and how to overcome them. My name is Jim Cosby. I'm our Chief Technology Officer for NetApp US Public Sector. And we're going to talk about how you can help secure data, optimize it, and also expedite operations around AI for non-kinetic dominance. So a little bit about NetApp. NetApp's been around for about 30 years. Our product and technology is about intelligent data infrastructure. That basically means doing more with less in regards to data, right? So we're going to look at how you can shrink the size, the footprint, the cost, the time to manage data, and also how you can secure that regardless of where your location is, whether it's edge, core, cloud, or even hybrid multi-cloud. And we're also going to touch on the fact that we partner with all enterprise applications out there, just about all of them in the industry, right? So whether it's cloud-based or enterprise on-prem, it can be IT applications from Microsoft, it can be virtualization with Red Hat or VMware, it can be SAP HANA, it can be NVIDIA, AI apps. We work with all of these partners everywhere. We do have tens of thousands of systems installed today running in Department of Defense around the globe. We also have systems in intelligence agencies as well as civilian agencies. You can see some of the logos up there, what we have. We have over 100 cleared folks and 2 SCIFs, so we can have those necessary conversations to drive the business at whatever level we need to. And in regards to certifications on security, we do have some very strong certs that help lock down data and improve zero trust. We'll talk through those in a minute. One of those is pretty key and significant is CSFC, okay? So, NetApp and intelligent data infrastructure, it starts off with data on tap at the center. The first thing that does, it is what we call unified. It can support any type of file, block, or object data. So think Linux servers, Windows servers. We don't care if it's object S3 data. You can do all of this with this storage technology all at the same time from one platform. After that, you start looking at 3 key characteristics, which are going to be efficiency, flexibility, and security. The efficiency comes in because we deduplicate, compress, compact, and tier the cold blocks of data out to lower cost mediums. So you can save 20 or 30, sometimes 70 or 80% of the footprint, the cost of the storage, and the time to manage it, regardless of where that is. Even if you're on-prem, or if you're at edge, or if you're in cloud and hybrid multi-cloud. Along with that, you're going to get that flexibility because data on tap itself is actually running in the major cloud providers you see here. So NetApp is running in Amazon, Azure, and Google. We can also support data on tap from NetApp at edge sites, and we'll go over some examples of how we do that in tactical environments as well. And then lastly, with security, we have lots of control mechanisms built in that can enhance zero trust. Everything from AES 256 encryption of data at rest, as well as during transit, and we can secure and encrypt data all the way from the edge, all the way back to the storage, whether it's from a Windows or a Linux host, whatever type of application you have. We also have AI capabilities built in addition to the efficiency I mentioned, we have something called autonomous ransomware protection. So this helps protect against cyber resiliency and ransomware attacks. And we do that by learning normal user access patterns to data. And we know that the warfighter is working 3 days straight, but then 2 days later they log in and do something at 2 a.m. That's not a normal pattern for that mission or that user. So we'll take a proactive snapshot, which is only a pointer-based copy of data in 1 or 2 seconds. And now we have a recovery point to get any file or data or all of the data back, no matter if it's hundreds of terabytes in size, we can recover that in 1 or 2 seconds. So that autonomous ransomware protection is very key. Once you have this framework or architecture of intelligent data infrastructure in place, you now have a modern data estate, as I said, that can support any enterprise application, cloud native application, whether it's virtualization, whether it's NVIDIA, even Palantir, and a lot of the other AI type softwares that are out there. So when you start to look at examples of how NetApp can be used, you can start to look on the left side here and you see something called ONTAP Select. So this is our software that can run on x86 standard servers. You could run this on HP, Dell, IBM, UCS, Cisco servers. You can run it on ruggedized systems, things like Packstar, Vector Data, these tactical kits. We run the software on that as well. There you can gain all of the security, efficiency, and flexibility of the data at the edge, even if it's not our hardware, even if it's on a standard x86 server. Below that, you see some of our controllers that start out in a 2U format. It's a 19-inch rack mount device. It can go from 2U up to half rack, hundreds of petabytes of capacity if you need that. And there are flash units, all flash. There are hybrid units for spinning drives, flash drives. You can have large data lakes and accommodate virtually any data set you want to. After that, when you start to think of the cloud providers, so I mentioned we're in Amazon, Azure, and Google. What you see here are the first-party services where these cloud providers have built enterprise storage offerings using our Data ONTAP software. So Amazon has built something called FSx for NetApp ONTAP. That gives you all of the file, block, and object storage, even in the cloud, the efficiency, and it is FedRAMP High authorized. It's in commercial cloud, it's in Gov Cloud, it's also IL2, 4, 5, and 6, and Amazon has that service running in secret and top secret today. So that is a very strong candidate for doing a lot of these tactical missions that want to be on edge, go to core, and then move up to cloud virtually any way you want to go. The next one in the middle is Azure NetApp Files. That's our largest flash arrays that Azure is putting into their commercial and Gov Cloud data centers. It's FedRAMP High, and they have it at an IL2 and an IL5 level. And then on the right, you have Google Cloud NetApp Volumes, or GCNV. That's file storage, CIFS and NFS files. That's our software running on their cloud. And right below that is something small called Google Distributed Cloud, or GDC. That's very important because that is a private classified cloud technology that intelligence agencies and Department of Defense agencies are using that is built on our all-flash FAS and our object storage called Storage Grid on-prem. So no matter where you are today in your mission, edge, core, you have the ability to flex and share and go to cloud anywhere you want to with this technology. And then lastly, you can run our software on a virtual machine in the cloud called Cloud Volumes ONTAP. That doesn't need any security certs because you install it on a virtual machine in your cloud boundary, and it'll pick up the ATO or the security credentials you have in that environment itself. So Cloud Volumes ONTAP is actually running in some private clouds, in some IL5, IL6 areas. It's also in the C2E or C2S private classified cloud as well. After that, you now have a modern data fabric or backbone, and these are a lot of the agencies and customers that are using us today, and they're gaining that security, efficiency, and flexibility across the spectrum. This also leads into multi-domain operations or mission partner environments where coalitions need to securely share data between them, and you can now do that between any agency anywhere using a common platform that's open and will talk to all applications and data. So this is showing our Snap Mirror capability. This is how we replicate data very easily across synchronous or asynchronous transmission lines. We can replicate from ruggedized tactical kits. You can replicate from our on-prem controllers or arrays to another array. You can go from on-prem to cloud. You can go from cloud to cloud. It doesn't matter where you want to go, but we replicate very efficiently and only change 4 kilobytes of data at a time. So if you're looking at a common operating picture or an image file that's 10 gigabytes, if you change 1 tile or 1 bit, we can update that 4K block to the other side in a fraction of a second or a couple seconds, and now you have the COP updated in 2 sites instantaneously. Along with that, this gives you backup, recovery, replication, HR, DR, COOP, because that primary site is read-write, the secondary is read-only, but the minute you have an outage, you break that dotted line in the middle, and now you can fail over and write at the destination side. If you recover the primary, you intelligently only copy the change data blocks back to the primary and revert back to the primary in a matter of seconds or minutes. And then lastly, on the far right, we have something called our Cisco FlexPod. We have a big alliance with Cisco. So think of this as a data center in a box. or a cloud in a box. And we can start out with Cisco UCS servers, Nexus switches, and our storage. There's over 180 validated designs on FlexPod, whether you want to run Microsoft Exchange or AI or whatever virtualization workload you want. You tell us how much you want, it's sized properly, you roll it in, plug it in, turn it on and go. So there's half rack, full rack instantiations of that, and it works great to roll out production level things to the field as you need to. So let's talk a little bit about the AI data challenge. 85% of all AI projects fail because of a lack of data, right? And the biggest challenge with why that fails, number one, data is spread out everywhere. Where is customers' data? Is it siloed? Is it on old technology? Is it in the cloud? Is it on new technology? How do you find it? How do you aggregate it? How do you get it together? And then lastly, you always have a constant threat on that data, cyber attacks, ransomware attacks. There are thousands of attacks per week on our governmental agencies out there, and the stats continue to grow day by day and week by week. So with NetApp and using our intelligent data infrastructure, we're going to be able to see that data and manage it anywhere, everywhere across that spectrum. With that data fabric or data backbone, edge, core, hybrid, multi-cloud, and you're going to be able to scale that performance as you need to. You can start out small on a tactical kit. You can move that data to a core site and run even large language models or high performance computing on it. You can roll it up to cloud and leverage all the cloud services you have in the cloud with that same data. And you're going to get that security built in on the data that we have, whether it's encryption at rest, during transit. I'll speak more to those security certs in a moment. So one of the things we have is a data science toolkit. This is very impressive because we have real world customers that we're spending 51 hours copying data around to restart their data learning models and machine learning models. With our cloning technology, we can make a writable snapshot of data in 2 seconds and share that between data scientists and organizations. So we literally have customers doing AI modeling and speeding things up, doing things in 6 seconds that took them 51 hours without NetApp in the environment. So think of instant time versioning your data. You want to create 10 or 100 copies in a matter of seconds and run your machine learning AI against that, figure out which one works, keep that one and delete the other ones in seconds. I've just saved days or weeks of time by versioning that data for AI behind that. And that data science toolkit plugs in natively to the data scientist environment, like their Jupyter workspaces. So with one click or one command, they can create a copy and share it, right? And then lastly, we have something called NetApp Trident in the center there. That's for Kubernetes applications and data. It is a provisioning tool that's open source, we maintain it, but it will create persistent volumes in your Kubernetes environment and then map in persistent volume claims, and it brings you all of the security and efficiency and flexibility of the NetApp data behind all of your Kubernetes applications, okay? When you look at larger AI instantiations, we do have superpod relationships and architectures that we build with NVIDIA. You can see here, it's usually their GPU servers, our high-speed NVMe storage, giving you extreme throughput. There's different sizes based on what you're doing. If you're getting into fine-tuning, remote augmentation generation, inferencing, that can lend itself to run better on smaller instantiations, so we can leverage standard OEM x86 servers, right? Whether it's using CPUs, GPUs, NVIDIA cards, we have ways to do that, tie that into these AI pods, and build much lower cost environments for smaller to mid-size environments than having to buy larger GPUs. We also have the FlexPod AI out there that puts NVIDIA GPU cards into the UCS servers. We can build kits out there for dozens or hundreds of AI scientists on that as well. In regards to cloud storage, we talked about NetApp having data storage in all 3 of the major cloud providers. And if you think about Google, we already have tied in our Google Cloud NetApp volumes with Vertex AI and BigQuery and the agent tools in the Google Cloud. So if you want to replicate your data to the cloud, you can leverage those services today. In Amazon, we have our BlueXP workload factory tools that work with Amazon Bedrock, and that's supported with the FSx for NetApp ONTAP storage in the Amazon cloud. And then in Azure, we have the Azure OneLake with our Azure NetApp files, and you can leverage and process your AI data in the Azure cloud as well. Again, we give you complete flexibility of anywhere and everywhere you need to take that mission and execute it. So looking forward, and you think about how are we going to innovate and solve this data problem, because data is global, it's everywhere. We've now come up with the architecture that we're releasing this fall that's going to have intelligent data services built into it. It's going to have a robust data engine to locate and find the AI data for you, and it's going to have the best infrastructure for that. We call this a disaggregated architecture. So on our storage controllers on the back end, we're going to build high-speed Ethernet networks, 100, 200 gigabit per second networks, or 400 gig either, and have all the disks and data shelves available to any controller anywhere. It's going to create a super speed highway to get to any data anywhere in that cluster. Along with that, on the right, you see an ONTAP data node. That is going to create a vector database. And what that means is, since NetApp storage can be edge, core, cloud, anywhere, we will go out with this data engine and figure out where your data is, whether it's in cloud, we'll write metadata for that, whether it's on-prem, whether it's at edge, and we'll build a vector database and have an API that the data scientists can reference. And literally you could be here and you could hit that API database and go get something in EUCOM, AFRICOM, INDOPAC in a matter of seconds or milliseconds, as opposed to churning through petabytes and petabytes of data trying to find it. So this global metadata or vector database is going to greatly speed up that process, and it'll have its own interface, as you see depicted here, for figuring out how efficient is the caching, where's that data located, can I speed it up, how do I manage it and make sure that's working really well. So in regards to certifications, these are some of the major ones we have. We have FIPS 140-2, FIPS 140-3. We have a DISA-STIG that took 2 years to complete. We are on the DODE and APL. We just finished updating that 3 months ago down at Fort Huachuca and Netcom. And we got our latest software and products all up to date there, so you're ready to roll and use that. And then we've got common criteria. And then one of my favorites is here on the left, called CSFC. So how many people have heard of CSFC in the room? Good. Good. I got about half the crowd there. So, how many people think that CSFC storage is available today? That's a trick question. Everybody should their hand up, because I have it on the slide. So NetApp is CSFC certified today. So that we do that with dual layer AES 256 encryption using a FIPS certified drive and volume level encryption on top of that. So you have dual encryption, you can share the keys with different security officers, and NSA says you effectively can handle secret and top secret data in more of an unclassed fashion, right? So we're the only storage solution to have that certification. Nobody else has that. So if you need CSFC certified storage, you get that with NetApp. The other thing that it does is it helps deal with PQC, or post-quantum cryptography, because people are worried about getting hacked and quantum cryptography hacking algorithms. If I'm dual layer AES 256 encrypted and I happen to crack it once, I don't know where I am, because I'm looking at ciphertext all over again at the second layer. So it can thwart and reduce the concerns around PQC as well. Okay, so no matter where your AI data needs to live, if it's edge, if it's core, if it's cloud, we're going to bring that integration and that intelligence to the data anywhere it lives, right? That security, efficiency, and flexibility. We're going to give you the scalability and performance to start small, start in the middle, start the high end where you want to go. And we're going to help secure that data, encrypt it at rest during flight, and help enhance zero trust with all the other certifications that we have. We can also build data segmentation gateways from the clients to us using encryption as well to lock it down even further. So a couple of use cases real quick. No matter if this is a real world battlefield situation or simulated, we can actually run our ONTAP software at edge and capture satellite data, drone data. We have these, our appliances running in ships, submarine, and aircraft, in the back of Humvees today, in desert tents. We have tens of thousands of these installed across DoD everywhere. And we're capturing that data, and we can forward the entire data set or what parts you want to back to the core, right? You can do infrastructure edge processing there, reduce that artifact, bring it down to more relevant data, ship the data or the whole set back to another site, further process it. As I said earlier, ship that up to the cloud, and we have agencies doing this today and then processing it in classified cloud on secure, secret, and top secret storage with NetApp in the cloud. And then once they have that artifact, that remnant, that common operating picture, the SATCOM to shooter coordinates, pass that back to the battlefield, right? So we can tie in the entire circle here of data flow as you need to ensure the mission happens, so it happens on time. So just to summarize, you can run our software on other people's servers or on ruggedized systems, right, to fit wherever you need to at edge. You can use our flash or hybrid arrays for any type of capacity. They're all connected with our replication capabilities from edge to core. And you can leverage NetApp data storage in the cloud. In all of those environments, you can connect and go from any to any. If you want to go edge to cloud, no problem. You want to go core to cloud, back and forth, Amazon to Google, over to Azure, back on-prem, doesn't matter to us. We're going to keep that door open for you. So you also have our BlueXP tool that gives you an IT canvas to see all of these data volumes across your environment. You can literally drag and drop a volume of data from one site to another, answer a couple questions, and you're replicating, migrating, disseminating, aggregating data as you wish. So a real world example could be something like VMware or file data. You might have 5 terabytes and we dedupe, compress, and compact that down to 1. You've saved 80% of your cost and time at one site. If you need to replicate that data to another site, guess what? We only move the intelligent data. We replicate 1 terabyte to the second site, save 80%, and it looks like 5 terabytes to all of the users at that site. No changes needed in the apps or the network or the software anywhere. And we can continue that on the cloud, right? So we save 80% in cloud, or cross cloud. We're also going to reduce those ingress and egress charges, because egress is really what gets expensive when you take that data out of the cloud. So we can greatly reduce that cost as well. Again, any enterprise application you want, cloud native, put on top of this, because we're using those POSIX data types, file, block, object. And this can be the underpinnings for any type of infrastructure, things like multi-domain. You're seeing some examples here of JADC2, JWCC, and the programs, ABMS, convergence, overmatch, and we're serving all these agencies today doing these types of things in a variety of locations, okay? So hopefully that made sense. That's what I had today, but if there are any questions, I'll take them, but thank you for attending.